This conference will now be recorded.
Fire away.
And one thing that it's keep actually coming from the last couple of meetings is Mark actually requested to find the CLA for releasing a spec. He wanted to be on the agenda, but I don't know. We never had the time to talk about it. I know
Yeah,
it's
no, let's unless everybody has an objection, I vote we finish a draft
Mhm.
ideally by the 31st, and then we'll come to the CLA. Otherwise, that'll take on a life of its own.
Okay. Then there are lots of opens item from Beluchita and Ilat side. I think Ilat, are you ready to?
Yeah, I'm happy to. Actually, I think this will sort of follow up on some of the discussion from last week on return loss with the various capacitance numbers we looked at least for terminated. It'll also show some data on the actual sort of crosstalk ISI profiles, at least for the alpha wave channel. And then I'll use that to sort of drive hopefully closure on one of the other items, because I think the data is fairly clear on that point, but we'll see. So let me just, I think, can you make me the presenter, Shahab or Buffy?
Yeah, 1 second, I'm going to make both of you guys organizers. You should be able to present. Would you please try?
Looks like it's working.
All right.
Just a moment.
Hey,
Okay.
just somebody has to please take ownership and generate an abstract within the next week for the November summit.
Oh, right. When does that due again?
Next week, end of next
Okay,
week.
I thought it was due Friday, this Friday.
Wait, God Almighty. Okay, keep going. Let me check. I thought it was 7:30. I thought it was.
Well, we'll figure it out. Yeah, we'll figure it out. Okay. So this is sort of following up a little bit on the discussion from last week where we had done some capacitance tallying. And the proposal I think we ended up with was that we would allow up to 300 femtofarads on each of transmit and receive in the terminated mode and up to 400 in unterminated mode. So I apologize for those who are focusing on unterminated. All of these will be in the terminated mode. I'm happy to go back and do unterminated things as well. But generally speaking, the budgets have looked much tighter in terminated mode than otherwise, so that's why I focused here at first. So maybe just give everyone a little bit of setup on what's being shown here. So I think this has been discussed, nothing is new here, but just to sort of document. So the alpha wave channel sort of mimics a 727 stack up with about a 20 millimeter route distance. Layer 1, I believe, is microstrip, and layer 7 is strip lines. So that's how it ends up with 7, even though it's a 4 stack. One maybe sort of important point in all this is that these are all currently deterministic simulations with ideal elements. The deterministic part probably being more important than ideal elements. I'll come back to that in a moment. So we are using 20 picosecond rise fall times. That was a little bit of a guesstimate from my part, and that we haven't actually set that in the spec yet, but I believe that's a reasonable sort of point to look at things. It is using an ideal transmit duty cycle. So in other words, there's no like difference between the width of consecutive bits. In this particular case, we're simulating about 3.2 thousand symbols. There's a separate PRBS sort of generator on each of the lines. I should have mentioned this channel model is a 10 port, so there's basically 5 lines transmitted and 5 receive ports. Intention being that you sort of use the middle one as the worst case crosstalk victim. So there's 2 on each side to sort of capture differing types of crosstalk you might observe. And there's just differing PRBS patterns on each of them, all relatively long to the length that we're simulating. I will say, at the end of the day, we should absolutely do a full statistical analysis. However, the channel responses are reasonably short. So I think these simulations are kind of good indicators of the trends and good for sort of making some, let's say, informed decisions. But please don't interpret any of the numbers I'm about to quote as being the actual available margins for anything, because again, this is not a full statistical analysis. So I guess before I dive into just some of the results, any questions on the setup or?
Gilad, I have a question. How about the channel loss, a standalone channel? How much loss we can expect at 8 gig?
Yeah, so all of those I believe are sub 3 dB insertion loss. That's kind of, I can pull up the exact S parameters, but they're all in that ballpark. Layer 7 has slightly higher loss than layer 1 does, just because it sort of bores through, sort of the preliminary, there's the via essentially included, plus a little bit of extra link. But none of them are particularly high loss. I think they're all sort of sub 3 dB loss itself. Crosstalk tends to be the sort of much more significant impact from a timing margin loss standpoint. And it won't be immediately apparent, but it'll be somewhat apparent, I think, when we see some of the eye diagrams that I'll show next.
Oh, so the question I have is, we don't know about the details about the package stack up. I think it's probably you're going to share it later. And the crosstalk, are you going to show how much is the crosstalk and how much is the standalone channel loss?
Yeah, so I didn't explicitly split that out at the moment, just because I sort of, these are the plots I've managed to sort of pack into this particular one. But so for now, take my word for it. I'll add that into the deck when I share it. The crosstalk is definitely the much more noticeable impact, particularly as you start increasing the sort of the capacitance to the levels that we're talking about now. So yeah, so maybe I'll sort of go through that, and it might be somewhat more apparent from the eye diagrams, but I'll go through that and we'll see.
Thank you.
Yeah, of course. There was one other thing I was gonna mention. No, I think that's. Oh yeah, sorry. In terms of the stack up, in the alpha channel model that I think I shared with you, and Javi had put the link to the directory to everybody a few weeks back. They did include the actual package stack up that they were thinking of there. It's intended to model a quote unquote reasonably worst case. Perhaps Javi can comment on sort of which particular aspects were intended to be the worst case. But my understanding is that it was a reasonably worst case stack up.
So the stack up is not so much worst case. What's the worst case aspect is the distance. Spacing that 20 millimeters is pretty long.
Got it. Okay, makes sense. Okay. Okay, so just a couple other things from a setup standpoint. And part of this is done, again, to sort of drive to another bullet point that we'll get to at the end. So in this case, I'm simulating the channel under varying transmit and receive impedance pairs, as well as varying I/O pin capacitance. So there's only two sort of pairs of transmit receive impedance that I'm using here for reasons that I'll explain. The first is having the transmitter be 58 and the receive 42. So in the current spec, that's kind of the worst case, right? Because obviously the swings you get will be small, and you'll have reflections, if there are any sort of significantly noticeable ones. And then the other case that I'm simulating, which is actually kind of even a little bit worse than we really need it to be, is a 33 ohm transmit and a 75 ohm receive. And that's actually, as I said, somewhat even more pessimistic than I think it would be if you sort of did it this optimally. But basically, that's just sort of show or provide some data on a proposal that Eric and myself had made at some point of recentering the transmit and receive impedances so that the transmitter one, still the same percentage variation, is centered low, and the receive one is centered high. And you'll see from the data that actually does seem like it, sort of provides you a decent amount of link margin back. And then in terms of the total pad capacitance, basically for each one of those combinations, we'll simulate it for 100 femtofarads, 200 femtofarads, 300 femtofarads. 100 is sort of what was implied from the previous specification. 300 is kind of the new proposal that we've been working with. So this is just really to quantify sort of, at least on this particular channel, how much sort of margin loss are we seeing due to that.
When you say pad capacitance, are you just talking about both, or are you talking about all the capacitance?
Everything, yeah. Basically, sorry, I should have been more clear. That is the sum total. So this would be the number that would go in, that we would use to compute the return loss specification.
Good.
Great. So then the last thing, and again, this is just to sort of clarify what the numbers mean. Right now we have quoted 75 millivolt receive sensitivity in the spec. We can revisit whether that's a reasonable thing to shoot for or not. But basically, everything is done here with a 75 millivolt receive sensitivity and 750 millivolt VDIO, which are kind of just capturing the default supply and the receive sensitivity that we're quoting at the moment. One other sort of important point is that all of these calculations do, however, assume that the receiver's reference voltage and timing are placed optimally, which may or may not be reality. So again, you should sort of take the actual margin numbers with the appropriate grain of salt. But these are just sort of telling you, essentially at least the trends and behaviors as to what we should expect to see as we move these things around.
Ila, sorry to ask, I think probably you covered it. This TX and RX models, whatever you have, is idle and lumped RNC, or
Yep, exactly. Basically, it's just a PRBS voltage source with a with a series resistance and a shunt capacitor on the transmit side, and on the receive side, just a parallel resistor and capacitor.
And the receive side also you have a similar amount of cap?
Correct. Yeah. So for all of these, we simulated the same amount of cap on both transmit and receive. That's mostly just because in our spec now it looks like we were going to provide the same maximum for both sides. I don't have the data included in this deck. Again, that can be, but in the past I have sort of independently checked the impact of adding capacitance on either side, sort of separately. And roughly speaking, the sort of slope is about the same regardless of which side you put it on from a timing margin loss standpoint.
Thank you.
Yep. Okay, so this is going to look like sort of just a long series of different eye diagrams. So what I want to first do is basically just show things essentially with the specs as they're set now for the transmit and receive impedances. So this is with 100 femtofarads, again, with rise fall time of 20 picoseconds. This is on the layer 1. Layer 1 is a little bit cleaner. We'll see layer 7 sort of after we go through the first set of results. And again, don't take this number as sort of something to bank on, but this is as you can visually see, this is a pretty clean eye. This is about a 75.8% timing margin available. Again, if you center everything perfectly. So this first sort of series of things I'll scroll through. It's just going to be increasing the capacitance linearly in these 100 femtofarad steps. So as you can see, when you go from basically 100 femtofarads to 2 femtofarads, you lose about 5% of your margin from a timing perspective. And it's maybe not immediately obvious, but if you sort of look in over here, and you can kind of see it too, this is kind of indicative of this really mostly being crosstalk, because it's not so much that you sort of see kind of traces that are bending over much more. It's really much more that you see a lot of fuzz around the timing transitions. And again, that kind of makes sense just given how short these channels really are, and the time constants that you'd get from essentially the terminated channel, driving this level of cap, those are very, very small time constants, so they don't tend to have that much of an impact. So interestingly, the sort of the slope of timing margin loss versus capacitance does get a little bit worse when you go from 200 to 300. So now we lost, almost about 7% or so instead of about the 5% or so. But this is sort of where we were sort of thinking to target the spec at. So there certainly is an impact. It still doesn't look like anything has fallen off of a cliff relative to sort of roughly where the specs had been set previously. But again, user beware, this is a deterministic simulation. Things, might be somewhat worse in the real statistical analysis. But it does show you that, yes, there is absolutely an impact from increasing the capacitance. But given that I think there was, largely consensus that 100 femtofarads probably wasn't very realistic, this does look like, that's kind of saying that, okay, yeah, we can still survive this level of capacitance as well. So I guess question?
Oh, I'm sorry, I have a question, especially if you look at the eye at the beginning of the eye, the slope is pretty sharp, is it right? So any changes, any imperfections in your TX or RX is going to close the eye a lot more. And the second thing is the 20 mm channel is our target, or what is the highest length we support, 50 mm or 20 mm?
Yeah, so I think there's actually maybe Bobby and others can comment on that. The spec right now says 50 millimeters. As far as everyone I've talked to, 20 or maybe 25 is sort of the longest that most people have sort of mentioned. And obviously these are sort of the alpha wave. Alpha wave was, again, intended to be somewhat worst case from a length, and that was around 20. So yeah, I don't know if Bobby and others want to comment, but I guess maybe just from a practical standpoint, 20 to 25 should be enough to get you underneath, sort of some other big chip that happens to be in your way, and get over to somebody else, unless it's a really, really massive chip that you're sort of trying to get around. So I suspect 25 is a very reasonable point to be at. Oh, sorry, just a second, I'm getting some echo. Yeah. But again, Bapi or Shahab, if you want to comment on why 50 was there initially, or Ken or anybody else, please feel free.
I don't see a reason for going more than 10.
Okay, great.
I have a hard time imagining that it'd be practical to go under another chip, but
Yeah, I've heard of people, I wouldn't let me say it this way. That's not something I would want to do either, but I've heard of people mention that they might want to do that. So
I'm not sure if this is the reason, but the 50 was there, or the 50 is the limit for the 112 gig XSR specification.
got it. Yeah, Bobby, Jahab, any other thoughts on that one? Or
Yeah, I think the same as Dave mentioned. I think the 50 comes from the XSR, but I think our plan was actually to get it to the 25, but we're gonna actually have the 50 on the standard. That was the
got
first
it.
initial thought.
Okay, fair enough.
Nothing
Yeah, I
from
don't.
me.
Sorry,
Sorry.
go ahead.
I don't have anything useful to say. Sorry.
No worries. Okay. So I think we've handled the questions on that one. So what I want to do next is, this is also going to be layer one, but now with sort of the skewed, meaning recentered impedances. As I said, I actually sort of push the recentering harder than you need to, in the sense of if you maintain the same relative variation, you can actually sort of come up a little bit on the transmit side and down a little bit on the receive side. But as you'll see in a moment, you actually gain back quite a bit of margin, particularly for the higher capacitance cases when you do this. So hopefully it'll be sort of clear that this is probably a good way for us to go. So yeah, so this is back at 100 femtofarads now, and then just to sort of make the comparison easy, so relative to the current spec, we're gaining back about 3 and a little bit % of margin, so it's 79 instead of 75.8. And that's mostly just because obviously you get larger swing this way than you do in the other sort of worst case by pretty noticeable factor. So for the same receive sensitivity, that just buys you back a decent amount of timing margin. So as we go,
can you comment on how much power and latency are coming into recentering?
yeah, to be honest, I think the biggest potential impact is just that you have to upsize the transmit driver itself a little bit, right? Because the driver itself, you're going to potentially support all the way, like you're recentering it like this roughly 10% lower than you used to, technically 16, I guess. So you have to upsize the transmitter a little bit. But from a sort of power dissipation standpoint, largely speaking, you don't have too much of an impact for kind of two reasons. One is you've moved the receiver up. So sort of the absolute worst case from a power standpoint would be that the receiver happens to be low and the transmitter also happens to be low. And then you end up with like, about 83 or 85 instead of 100 as being kind of the supply resistance that you would see. But again, the termination power at these rates tends to be not that big of an impact. And from a sort of a sensitivity standpoint, this just sort of buys you back a lot that from a received design standpoint can be pretty hard to buy back otherwise. But there definitely is a sort of roughly speaking 15% hit you would take on the kind of the transmitter size, and at worst case 15% hit you take on the DC power. In best case, you actually get a little bit lower power, but that's a different story. Does that make sense, Avi? Or?
Yeah, it makes sense. Thanks.
Of course.
Gilad, I have another. I think it's probably a philosophical question. Why are we sticking to 50? Why not 60? That gives the channel impedance of 60. That gives more power savings.
No, one could certainly play that game. I don't have a personal, let's say, bias against that one. Some of the sort of people who are sort of doing the actual package designs and etc. 50 is just sort of like the magic universal standard that most everyone works against. And so a lot of things are just built around that. Yeah, go ahead.
You might get better pitch if you went up a tiny bit.
Yeah, no.
It's actually pretty reasonable.
Yeah, no. I mean, so I think we might want to turn that to. I don't know if Javi's quite the right person, but if there's anyone on the sort of system or package side that sees any issues with that, they should probably speak up now.
So we looked at impedances, and at 130 micron bump pitch and 65 micron wire pitch, it seemed like we could go down to 40 ohms. We could go up to 50 ohms. We didn't see that we could go much above 50 ohms.
Okay, yeah, no, I mean, I think that the only advantage of going slightly above is that it just reduces power, right? That's it. Well, possibly, you know, if you're not.
I mean, yeah, depending upon what your layer thicknesses and restrictions are, technically a skinnier line is a higher impedance, and it might give you the ability to pack a little denser.
Right, they just may not have that.
I don't think it'll get you an extra line through.
Right.
So.
Yeah, so I think that's an interesting sort of, let's say,
Shrink the transmitter size.
Yeah, it would shrink the transmit size a little bit. Yeah, I mean, I think there's a little bit of space there. So I think it's probably a reasonable idea to write the standard in a way that doesn't preclude that from happening. Which I think basically we can do by just basically, you know, we say that, okay, you know, the transmit impedance must meet at least sort of, you know, this range of plus minus 16% around, you know, whatever we decide the centering point to be. But that wouldn't stop anyone from tuning beyond that point if they would like to. Does that make sense, or?
Yeah, I think it's only the reason I'm bringing up. Some of the D2D, they're using 60 and 75, and there's quite a bit of power savings, especially if we go to 75. 75 is the tough one, but 60 seems to be people are doing it. I'm just wondering, since it is new spec, why are we still sticking to the 50? And the channel is also pretty shallow, is it right? Yeah. That's the reason.
Yeah, no,
are they using that higher impedance in laminate, or is that in a interposer?
I'm sorry?
Is that higher impedance in laminate?
I don't have the details, sorry.
We didn't see a way to get to that high an impedance in laminate with 25 micron minimum line widths.
Right. So the the minimum line width in build-up substrates now is trending towards 12 micron. 12 micron width.
Oh,
so with that,
okay.
you are able to get to a higher impedance.
Okay. So I mean, I've got no objection to allowing it. I've got no objection to allowing it, but I don't think we should mandate it.
right.
Right.
Okay, yeah, no, I mean, I think maybe the right way to handle it is we'll sort of say that we'll sort of basically say that, okay, hey, look, you know, at minimum you need to meet sort of the 16% variation around. Well, okay, so I guess the decision point would be, do we make people meet 16% variation around, you know, the nominal targets, where the nominal targets are sort of derived from 50 ohms, or do you just say, okay, it's 16% variation around whatever your target is, and then it just means that, you know, if somebody's designed for a 60 ohm system and somebody else was designed for a 50 ohm system, you know, you'd have to sort of go and you know, put them together and see what really happens.
For short links such as this, it's probably, by 25 you'll start to see a little bit of impact, but under 10, it's negligible.
Any thoughts on that one, or?
I would prefer the first option you had.
Okay, in other words, we'll nominally drive everything from 50, but then
No. The other one. Okay, then I had them wrong in my head. The one where you design whatever you want, but you know, at some point it should meet plus or minus 18% should include 50 ohms, basically.
Yeah.
Okay, yeah. The trickiness is that if we do this recentering trick, well, yeah. Maybe I'll go through the rest of the data and we'll see if we actually want to do that. And then if we do, then you know, we'll have to plumb that all the way through in terms of the implications. But I think I understood the preference.
Well, at least let me, you know, from half-baked knowledge, I think if you sort of say around 50, you're penalizing achievable performance to force interoperability, and it should always be the other way around in my mind.
Other way around, meaning that
you should
yeah, go
penalize
ahead.
interoperability for performance in the sense that, you know, this is the first generation of the spec, right? So if like a year from now, you probably, if there's enough people and you achieve interoperability, then we might settle on 60. Sort of preemptively forcing at 50 seems to say you're valuing interoperability more than somebody generating a family of devices that they want to.
Okay, no, that I'm good either way.
Anyway, that's my only reasoning. That's about it. Is what I'm saying.
No, makes sense. Like I said, I'm good either way. As a side note, I don't currently have any channel models that are 60 ohms, but you know, but that's a different problem.
And it's a little more problematic to set up your network analyzers and such.
Right. Okay.
But
So,
I'm under the impression that's the way it's trending, right? At least that's the way I'm hearing Javi say that's the way it's going on Satya.
I'm not saying so much that it's trending that way, but it's possible. And creating an additional model later that has 60 ohm lines is not that much more work, so we can do that.
yeah, that'd be great. Yeah, I mean, I think we can reasonably easily write the spec in a way that would certainly support that, but not mandate, you know, one way or the other. Okay, so just maybe to continue a little bit on the data. So when we go to the 200 femtofarads, you know, you actually buy even a little bit more back. So now you're closer to around 5%. And then we go all the way to 300 femtofarads. You know, now actually you get almost, you know, actually a little bit more than 8% back from a margin standpoint. And so again, this all sort of makes sense, right? All these channels are fairly short. They're not, you know, especially lossy. So, you know, reflections tend to not be the dominant effect. You know, it's really much more kind of crosstalk that you know tends to be the issue here. And so again, it kind of makes sense that you know you're able to sort of play this trick. And for those who are familiar with kind of some of the memory interfaces, they play this trick fairly commonly as well. So I have a bunch more data on layer 7, which is kind of just the same set of progression repeated. I guess maybe, well, yeah, maybe I'll just flash through that really quick and then we'll loop back for questions. So layer 7, this is again with 100 femtofarads, the default specs. As I said, this one's a little bit worse, so now you're at like 73.6. Again, as you increase the cap by 100 femtofarad steps, you lose, you know, nearly 8% in the first one. And actually even more, you lose about, you know, almost 12% in the second one here. You know, layer 7 really is the, you know, sort of the more painful one from this perspective. But then once again, if we play the recentering trick, we get back, you know, about 5% with 100 femtofarads, about 4% here, and about another 7%, you know, sort of all the way when you're at 300. Eric, you got a question?
Oh, no, the updating is a little bit slow, so if you're going through quickly,
got it.
You'll get it, at least for my link.
No problem. But yeah, but basically the sort of the conclusion of all this was that, you know, there's consistently a 5 to 7 or 8% sort of margin buyback that you get from sort of skewing the transmit versus receive impedances accordingly. Okay.
Layer 7 is worse because of what?
It's worse for two reasons. One, you're VAing through the stack, which is, you know, I don't think that's a substantial contributor, but is there. And just because layer 7 is farther back in the stack, physically on the die, it just traverses slightly more distance.
Okay. We don't see a particular difference because of the microstrip versus strip line.
There could be that too.
That'll give you
I
a
would have
little bit
expected
more.
microstrip and the strip line to be better, but yeah.
Yeah, the microstrip will be a little bit lossier, right? So I'm sure the strip line will be slightly lossier because it's got the dielectric on both sides of it.
True. True. Although I mean, it's true. It is slightly lossier, but crosstalk wise, you also should be doing a little bit better.
Oh yeah,
you know,
absolutely.
Yeah, it might be the vias actually that are causing it. Yeah.
Also, the microstrip often has there's some kind of coating, you know, the solder mask or something on top, and that's not exactly the lowest loss stuff. So.
Yeah, in the current design, we have the first slice has traces that go straight across and connect to each other and don't need to go around the via. All of the lower layers had in this first iteration had the vias for VDD go down and the traces had to go around it. and it bunched up a little bit as you passed by it. So we're gonna work on a variation of that, where those blockages are no longer there, and all the traces are straight shots on all layers. So it'll be an improvement. So I'm hesitant to say when that'll be available, but we'll go ahead. But it's in the queue.
Got it. Makes sense. Great. I guess any other questions or?
Well, it seems like all these results are within capture range, aren't they? I mean, 60% timing margin is still looking relatively clean.
Yeah, I mean, again, with the caveat that this is all just, 3,000 symbol, deterministic simulation, not a real statistical analysis at 10 to the minus 15. But with that caveat, stated, yes, well, I guess I'll be a little bit careful. It depends a little bit, kind of, what your budget on the other side is. At 16 gig, losing about half of your time, doesn't leave you a whole lot left for all kinds of other error terms. And as I said, right, for example, there's no duty cycle error here. There's no residual mismatch between between lanes here. So there are a bunch of other terms you have to subtract off from it. But relative to the approximately 50% eye opening we sort of have in the current spec, yeah, they all look like they're in the right ballpark. Other questions or?
What was the layer 7 5842 350%?
That one was 53.8%. So there's about a 6 and a little bit percent sort of margin that you buy back from the reskewing trick in the in the worst case.
Uh-huh.
Yeah, and I'm sorry, I was going to create like a big table at the end for comparison purposes, but I ran out of time. So.
Well, probably, I'm not sure whether you have a data. Based on your prior experience, let's say if this with the ideal TX and RX without any clock jitter, without any TX imperfections, any skew between the lanes, right now it is 53.8. It seems to be on the edges, right now, or 60% timing.
Yeah, no, exactly. That's what I'm saying is, given that this is a deterministic sim and things will, very likely only get worse from here. I don't expect they'll get tremendously worse, but they probably will get worse. So whether or not we're still about 50%, precisely at that point, that I'd have to guess. Probably not, but that's just a guess. Well, I guess I should be careful. I mean, purely even from these ideal things, right? If you start subtracting off everything else, you're definitely below, right? If you do 1.5% duty cycle, and I think we had like 3%, sort of skew between lines, right? So I think, once you add those in, you'd definitely be below 50%. I'm not sort of zeroing on that one too heavily in the sense of, there is sort of this global spec game that we're still sort of working our way through in terms of which things to put where. But, from a nominal standpoint, yes, this is, without the recentering, it's definitely getting, the chest pressure is increasing. Let's put it that way.
So do you think that the 75 millivolt receive margin is a good target, or I think I heard you say that you thought it should be larger.
Yeah, well, so basically, I think a lot of it depends a little bit on some of this philosophical discussion of, do we want to make sure everybody kind of works in this, reasonably worst case, or not? For the reasonably worst case, I think you probably do need to be around that 75 millivolts. That's probably not the easiest target in the world to hit, just given all the sort of various error terms you have in these single-ended links. Whereas if you're sort of more interested in, well, okay, like, not everyone's going to work in these reasonably worst cases, then, you probably could back off some more from there.
Right. If you just try and like break down, sort of do a reverse error budget kind of thing on the 75, just throwing some numbers out, and every number can be adjusted. But, noise on a high speed, front end for data, somewhere between 1 and 2 millivolts is kind of the right RMS value. And you work that out, that eats that at 2 millivolts, it's at 35, that's half of your budget right there for the 75, just rough numbers. And then you want to have the discussion about offset, which is going to be a good sized chunk, unless you want to postulate how you're going to background correct offset or one time correct it and deal with drift. And then you have ground errors and other level setting errors and resolutions and so on and so forth. So it's not looking, particularly generous budget.
That's my worry too, Eric. I think one of the thing is actually what you are looking at is 37.5 millivolts, is it right? Yeah.
Yep.
Get the common mode point of view, and you need to take the common mode variations. I don't know how you guys are generating the common mode. There could be multiple ways. And even then also you need to add that one, as you said, like a ground bounce is another one we need to consider, because they are too off and they're 20 millimeters apart. And the ground bounce could be a significant portion of that. And on top of that, your receiver mismatch, and whether we are doing offset correction or not, that is also going to be a big contributor. And third one is, I think you have two modes. One is terminated and unterminated mode. So your receivers, either you have two receivers or a single receivers. I think it's all those things into the factor. Looking at those factors and power budget, 37.5 seems to be on the edge, my point of view.
Yeah, no, it's not a comfortable spot to be at.
Right.
Having said that, you can almost visually see it. If we back off to like 100 millivolts, you're going to lose. I think it's. I could try and estimate it in my head, but I won't. I think you lose a good 5 or maybe even 6% of UI of margin, maybe even more than that. Depending on which channel it is we're looking at. So in fact, actually, probably these are the. If we go back here, then you lose even more. Yeah, so that's obviously there's kind of a global picture here that is the one that we all sort of need to resolve together. I would say that Eric and myself sort of thought of this recentering thing, or were reminded of the recentering thing precisely as we were going through this exercise and looking at, okay, hey, like if I really don't have if I want to make the receive margin a little bit more comfortable, what do I have to do? And definitely, you buy back a good chunk of it from just skewing the impedances accordingly, so you don't have to deal with the absolute worst case swings. I guess any other thoughts, comments, questions?
Wait, so the layer 7 affects stacked BoW interfaces, right?
I mean, hypothetically, yes. I mean, for some bizarre reason, somebody might use a layer 7, on without a stack. I don't know why. Well, I suppose if they're going underneath some other chip or something. But mostly speaking, yes, it's probably a stacked interface where that matters.
So you're looking at the layer 7 would be 4 stacks in?
Yes, that's a 4 stack. That's correct.
So you're looking at 4 stacks in. So if you're looking at 16 times 256, so you're looking at a terabit per second as a 4 stack interface, basically.
Mm-hmm.
Instead of using beachfront bandwidth.
Right.
That's
yeah,
the working theory.
I mean, just to clarify, like, I think there may be scenarios where people will desire to use a quote unquote layer 7, without even necessarily requiring the terabit per second. We can debate sort of those scenarios, validity or not. I think more generically speaking, I think there's kind of a philosophical decision for us to make of, what do we want to consider the quote unquote worst case, where the quotes just means, what's the channel or set of channels that we all say, yes, these are things we want to be able to support. And once we've decided that, we can drive all the specs accordingly. And vendors may do better, may do better than that if they realize that there are reasons that they want to do so.
So way back in the objectives, I thought we were aiming for about a terabit per second, right? On average.
Probably predates me. So.
Well, I also don't know exactly what was that per beachfront width of one slice or?
Yeah, so you hit the nail on the head. I don't think we ever said that.
I mean, we were talking about a terabit link in the context of 5 gigabit.
But what we were aiming for was a terabit per second per mm of chip edge, basically. And so I'm not complaining. I'm simply saying is at least in our, and I think we were looking at what if for mm how many interfaces can you go sideways for 1 mm of beachfront?
It's only one slice for 130 micron bump pitch.
One says, yeah, okay. Yeah, in that case, yeah, then this becomes, this is sort of, we'd have to do this to meet our, unless but at that point, we're looking at the magic turbo mode, but this is without the turbo mode for all practical purposes.
Right.
And at least the original one was looking at micro bumps that we could go deeper in with micro bumps in a way that you couldn't with.
No, I mean the micro bumps also buy you just horizontal pitch, right? Like you get a pretty large factor just from that.
Right.
Yeah, yeah. No, the stacking, the stacking was with my micro bumps. I think somebody was crazy enough to look at 8 as well.
Right. No, I guess what I was trying to say was, if you go micro bump, you can probably hit 60 micron pitch, pretty
True.
conservatively, and more aggressively than even 45 or 50. So that already buys you like a factor of at least 2 just from that.
Although you need the micro bump technology both on the die
Right,
and
of course.
the package.
Of course.
The package can be.
Yeah, so I guess maybe before we sort of get into the next piece. So if we're still on alignment that this nominally 1 terabit per second thing is kind of a good target for us to try and standardize around, and I certainly think layer 7 seems like it's a reasonable thing to include. I guess maybe are there any further thoughts or sort of other opinions on that one or?
I think it's reasonable to include, yeah.
Sorry,
because just given that you can get 4, do a 4 stack in the commonly available 727 package, I think a lot of people are going to want to do that.
Yep. Sorry, Satya, I think you were starting to say something.
Oh, I'm sorry, sir. So I think it's our interface sitting at 2.5, is it right? One TX and RX together. And from bandwidth point of view per millimeter, it is much less than 1 terabit.
Oh, I guess maybe that's a good question. So, Bobby, when you were saying 1 terabit per second, was that each direction or total?
No, that was that was just the chip edge in. Oh, maybe we were.
In other words, is it this terabit
no,
count as my chip is transmitting and receiving, or yeah?
Well, it doesn't matter, right?
No, it does. It's a factor of 2, unfortunately. Like in other words, if a terabit per second means my chip transmits a terabit and receives a terabit, then it's actually 2.5 millimeters ish for the pitch of 1 slice, quote unquote. If a terabit means I either transmit or receive, then then it's half that.
Is it duplex or simplex?
Right, exactly.
Oh, no, I don't remember any notes, but fundamentally it's like a terabit per second, which you can distribute in any which way you choose. One way in.
Okay, so that is, I think you're implying simplex.
Yeah, it'd be 512. No, we just sort of said like terabit per second per chip edge. That's it. We didn't specify direction. I'm looking at what we have in the.
No, whether these are all spec games, right? But I think you're implying simplex. Whether that's what people really want or not, different question. But yeah.
Well, excuse me, and probably I'm missing something. Whatever the answer is, whether it's 2 or 1 or half a terabit, what's the relevance to the discussion right now? How does it affect this?
Yeah, I think the only question would be if for some reason that drives you to say that the types of channels we're looking at are not relevant, then we might discount some things. But I think so far everything has pointed to, yeah, the channels we're looking at now are indeed relevant.
Okay, and then semi-related question as far as like, do we assume, all the way down to layer 7? Just more generally, I guess sort of the observation that the more we worst case, and maybe for reasonable reasons, but the more we worst case the assumptions, the more we're putting burdens onto the PHY design that burdens every user of the PHY design, even if they're going shorter distances, less layer stack, all these kind of things.
Yep, no, that's absolutely the trade-off.
Right, and so, I mean, I guess it was a question of, do we have just one spec that's the absolute worst case that burdens the majority of people with more than necessary? Or, I don't know, do you somehow have like a ranged form of spec? Or I don't know, but just observing that, it's great to have like, worst case everything, but there is a cost to that.
Oh yeah,
And
no,
that's the right trade-off.
Right, no, absolutely. Certainly we can partition things, under, distance might be a good proxy, might not, anyway, so there are partitions we can imagine. I do think that a relatively good way of sort of supporting some of that is kind of somewhat similar to the discussion we had previously of, if we just say, okay, the transmit and receive should each pick, sort of a nominal impedance target that they're going to work against, and then we can decide if we play this recentering trick or not. But either way, we just say, okay, you pick that impedance target, and then you sort of, you allow X% variation around that, and different people can choose different impedances, and even if you chose 60, you can still operate it on 50, as long as you sort of have enough other link margin terms. So that might be sort of a good indirect proxy for just allowing people to trade things off these ways.
So I think there's other dimensions of that trade-off. For instance, the termination, not termination, or the fact that you don't have to have full swing, you're allowing reduced swing.
Right.
So I think there is back off room so that we don't penalize everybody. Maybe we could define a narrower set of cases that everybody does have to work, and that, essentially from there on you can back off and save. So maybe full swing terminated is the one case that everybody's got to hit, and then it's optional to.
Right. And then the question would just be, with that full swing terminated, on which channel?
Yes,
right?
Yes. No. It doesn't eliminate the whole thing, but there's more dimensions that we've already sort of agreed to. That we were going to play. Right.
Yeah, two things. I think is the reason why it is relevant is because we are specing something 1 terabyte, and the way you look at it is also matters. If you want to have a 1 terabyte per millimeter that includes a trans receiver, that is totally different. That is going to break everything. Yeah. So I think that's the reason whether we clarify the spec or not, that is up to us, is it right? So, but we put something 1 terabyte per millimeter. Is that still valid, or we want to get away from that? That is the reason I just want to brought up, and we need to make sure that we clear on that.
Yeah, I mean, I think maybe somewhat more generically, I think this also just comes back to how bad of a channel do we want to sort of, force everybody to work over, and then we'll still have knobs that people can sort of back off, when they're on better channels than that, and arguably people can also design better than that if they believe they need to. But it's just a question of sort of, which stake we put in the ground for the spec that says that everybody has to work at. Yeah, and that's a if the preference is more for basically allow people to get the best performance they can, and perhaps sacrifice some degree of interoperability, then that would imply that we shouldn't spec everything at sort of the worst channels that we're aware of. We should spec it kind of at a more intermediate channel, but then people may know that they actually have to do better than that, to really really work on certain cases.
Yeah, I agree with you, Ella. And my thinking is I think if you look at most of the spec, they have a reference channel when they do the compliancy. I think we'll go to the compliancy later on. And depending on the compliancy channel, we should be able to meet. Beyond that, I think system designer interest is right. The whole system has to work work depending on their what you call channel plus transceiver characteristics. They can do here and there. That is up to them. But when it comes to the compliance, they need to meet some standard. Yeah. That's what the spec is supposed to spell out. Yeah.
Yeah, no, that makes sense to me. So I think maybe the sort of the relevant bit, well, maybe two relevant bits, but I'll, the maybe first ones first. So I guess the first relevant bit is, well, maybe even before that, I'm going to assume, and if anyone would like to suggest otherwise, please feel free. I'm going to assume for the moment that since that's the one we've got, and it was sort of supposed to serve this purpose, that we'll use kind of the alpha wave channel as sort of the reference for the moment. Under that assumption, do we want to take layer 1 as the reference or layer 7 as the reference?
The reference in the case of what we're going to get to meet spec.
Yeah, in other words, reference meaning that like when we derive all of our specs, we'll sort of make sure that we actually work on that channel.
So I guess I would favor doing layer 7 because I think that the people are going to want to stack these things.
Okay, yeah, that, I mean, sounds reasonable to me. If anyone else have any other thoughts or opinions?
Yeah, so it makes the most sense. That's going to be the worst case, right? So.
Well,
And again, I think the only trade-off there is the worse of a case you pick is what everyone has to meet. There may be decisions that become baked in that you will not be able to, that every transceiver will have to sort of pay for because it wants to be compliant.
yeah.
Yeah, so I guess my question on this is, it always makes me nervous. Are you penalizing bread and butter designs for a terabit and above designs? I'm asking, not commenting.
Yes, you are.
And is that sort of counter to what we started out with as our goal?
Sorry, Bobby, did you mind repeating the question real quick? I didn't catch the beginning of it.
Oh, can whoever said yes, we are, answer it for me?
Yeah, so this is Eric. Yeah, so are you penalizing bread and butter designs in order to hit the terabit per millimeter of edge goal? And the answer is yes. I mean, if you look at the original spec, there was a lot of attention paid to lower than 16 gigabit per lane, and certainly some people who are going to work down there. So you're absolutely penalizing them in some respect. Now, it's strangely quantized, right? I mean, are you going to push people to do something like take care of, offset correction or something? Or are you going to raise people's power budgets because of noise? Or are you going to limit the swings that people can drop down to and therefore raise the power? So there's definitely a price you pay to say we got to hit this high speed, unless you want to have tiers of parts, which is a whole new complication.
Maybe one small thing, because I think, at least at the moment, at least the way I intended to phrase the question was, so what is our reference channel, which may or may not touch on these other, things indirectly.
Right, I think, but the question that he raised was a slightly different version of it, which is if we push so that everybody has to work in the highest performance application, then the ones that were intended to be more pedestrian end up carrying baggage in terms of power, area, design complexity.
Right, no, but so I guess we should be careful. So the data as it is right now was intended to only imply things about the terminated high-speed mode. There's still the unterminated mode, and there's probably, I don't expect anyone will be doing 20 millimeters unterminated unless they're at much, much lower rate.
Right, the point is, if you're still building stuff in, because the goal is sort of everybody has to be able to hit this terminated high-speed mode.
No, that's what I'm trying to say is like, we're not saying that everyone has to hit the terminated high-speed mode. We're just saying that if you're going to support terminated high-speed mode, here are what things you have to do. You don't have to support it, right?
I really don't want us to mandate 16 gigabit mode.
Right.
Right.
I think part of the original goal here was to for the overall spec was to allow people to do a simple implementation. And 16 gigabit is, it's a more difficult thing.
Right.
that will be quite a bit more difficult in an older process.
Right.
But
No,
will,
no.
will
So
it be
I
will it
think
be a different channel model per mode? Is that the
exactly. We'll
okay?
need a reference channel per mode, right? Like,
Okay.
so layer 7, may indeed be the reference. Layer 7 20 millimeters is probably the reference for the 16 gig, terminated. I suspect that will not be the reference for the unterminated modes.
Well, I'm not. I don't think. I think layer 7 might still be the right choice for unterminated modes, but we don't need.
16 gig.
I would advocate looking at shorter distances.
No, exactly. Right.
Right.
Sorry.
Or not
yes.
16 gig.
Well, both actually. So,
Yeah,
right.
and
No.
more.
Right. And I'm sorry. I didn't. By layer 7, I didn't literally mean layer 7. I meant this particular alpha wave layer 7 channel. But you're absolutely right. I think something that's on layer 7 unterminated but is much shorter distance. Yeah, that's a very reasonable reference spec for an unterminated mode.
For all
Hey,
cases.
okay, can I?
I
Sorry,
wonder
guys. I want to
Go ahead.
hijack the meeting for the last 2 minutes and maybe spill it over into a couple of minutes of the next meeting. The spec, all of some, how do we get? Let me organize my thoughts. All the wonderful stuff Elad's doing is sort of saying what is in the spec is valid or not, right? If I understand this general application, it's not to say that the spec needs major revision, but it's that you're validating the claims made in the spec. Is that a fair way to look at it?
Yes and no. I think there are some things that we are going to have to change, right? So, for example, the 300 femtofarad thing, like definitely we will change the return loss spec.
Okay.
But yeah, and again, it's a little bit of a multi-dimensional thing in that decisions we make in one part will obviously impact everything else because it's an overall budget. So I was trying to go through sort of at the ones that I thought would have the most impact first, so we can sort of drive other things
Okay.
accordingly.
So sorry. So let me break it into 3 parts. There's one which is the structure of the spec. There's 2 just being ignorant. There's 2 which is the specifics of the spec. They're about the capacitance and anything else. And the third is that maybe that's basically it. So in terms of the structure of the spec, are we missing anything big? Does anybody see like there's any massive section that needs to be in place?
I don't think so. There's probably some like additional tweaks here and there we have to make about language and what's required versus not. Well, whether it's an additional section or not, that maybe is a different question. Like there are definitely some items that are not included in the spec right now that will need to be. So things like PLL jitter or transmit duty cycle or things like that. But that doesn't necessarily require an additional section. It's just more stuff we have to fill into existing sections.
Okay, is there anybody who's willing to, it can't be me. Is there anybody who's willing to make a quick decision within the next few days on whether we need new sections in the spec or not? I've tried to keep it up to date. Is there anybody who can get back to me with some feedback saying, yeah, the sections look about right, and we really don't need to muck with it? I'm sort of trying to find a glide path to releasing at least on the web. Okay, we've done everything we can within the next couple of weeks. Anybody who's a regular listener willing to look at the spec and say, yeah, I've got all the pieces I need.
Yeah, I mean, I'm certainly happy to do that. At some point, I was going to try and sort of get through all these other things first, and then sort of I was going to make a pass through regardless. So I'm happy to do that. At some point, it may not be sort of immediately, but I'm happy to do that at some point.
Okay. Okay. So Ila, then is there anybody else who can volunteer to look at the contents and say I can certify for you guys that we're in decent shape?
I can do that.
Awesome. Thank you so much. All right. Okay. Then if we get that out of the way, then it's a matter of adjusting the contents to match the results of the simulation you have, right, Elad? Is that fair?
Results of the simulation and just additional items that currently are not covered. As I said, I don't expect that necessarily needs an additional section to it. It's just more data we have to add into existing sections.
Okay, perfect. All right, then Ken, Elad, Shahab, Satya, Javi, anybody else, John, anybody who's looked at it, if you could please do a scan of just say and feel whether we're on track to be done by the end of the month, at least in terms of the, then the only adjustments we'll have to make out of the numbers, that would be a really good thing, so that we're,
Okay.
Ela, do you see like us being able to knock it off by the end of the month based on the rate at which we're going?
Yeah, that's gonna be tight, but I'll keep pushing.
Okay,
I think we can get there, but what I think should happen is that we should have some careful review of the whole thing by several of us,
Yep.
yes.
rather than just saying, okay, here's the final edits, now push it out.
No. So that's my intent. By the end of the month, I want to
Okay.
release it for that's it, and then give people about a month after that to and aim for the end of August, sort of by Labor Day, to be able to say, okay, we've got both a released and a reviewed draft, and we can turn our attention to actually officializing it.
Yeah.
Okay. Perfect. So then, in that case, that's all I need. Thank you. And then I will get back to you guys with the date for the abstract. Thank you so much. I
Thank
took
you.
up more. I'm going to stop recording and record again. Give me 1 sec.
This conference will now be recorded.
Okay, we're on to the test chip meeting. Let's see. I keep let me pull up the email I sent to everyone. Give me 1 second. Elad, I got your email. I was hoping to sort of settle it today, one way or the other.
Yeah, sounds good. Thank you.
Excuse me for 1 second while so what I'd like to do, yeah, it's easier for me to just find it. Yeah, got it. Okay, here I found it. Appreciate your patience. 1 second, I'm almost there. Okay. For everybody else who joined the test chip meeting, I've been making a good faith effort to keep the BoW spec up to date with the draft version. So you should be able to find both in the drafts folder 721, if I have it right. Yep, 721. And I'm trying to keep this spec, the HTML version, up to date as well. Okay. I wanted to have a discussion about this to see whether this is a good idea, whether this makes sense. My plan is to put together a sort of a 90-minute or 1 or 2 hour thing, which DJ and anybody else can point everyone to and say, look, this is what we're building. This is the amount of funding we're raising. Just a sort of single point of reference, and use that as a kickoff for this bring up flow, which is a big gap for me. That's what I thought in my head. I'm happy to listen to anybody who thinks there's a terrible idea, different date, whatever. That's it. That was like, I wanted to discuss this first.
I guess as I mentioned in the email to you, the date, unfortunately, I would need to shift.
Okay. So let's separate this into 2 things. One is, should we do this? And then the second part is, when do we do this?
Bapi, I think it's a good idea. We should do it.
Okay.
So I think I agree. I think we've gotten to lots of details in many meetings, and I think the high level picture is a good idea to sort of go through every one of these topics and few more if we've missed any. I just don't know if Friday is too quick, right? Too soon for everyone.
Yeah,
Okay.
same here. I think Friday might be a little too quick. But I share the same thoughts as Anu, right? I think it's time to kind of close the loop on a lot of these topics.
Should we aim for 1 week from Friday? I'm trying to remember. Okay, when do we do this? Like, essentially, I don't want the meeting to devolve into a discussion. Then I think we'll sort of go. It's really more a summary meeting of this is what we've agreed to so far, and these are the opens we have so far, right? Because if we have one more meeting where we dive into the opens, we'll all be dead again. We'll never get anywhere.
Yeah, I think if you want a 2-hour slot with the Friday meeting, then you need to do it the week that the business work group meeting is not there, right? That's kind of what you're aiming for.
Yeah, or we can just move them aside for 1 week.
Yeah, exactly. And that's probably why you did this Friday. But yeah, maybe a week from now would be better. I don't know, because to be honest, there's lots of other people who've got time on the slot, so I shouldn't be speaking for them.
Well, well, you should be speaking because I was going to pencil you in for something, but I'm glad you're here. So
I knew it, Bapi.
So maybe, okay, let's do this. Which ones are we ready for? Which one do we need more work on? Maybe that's, let me bold or underline everything that we're ready for. Start there. So are we ready in the sense that we're ready to have a 10-minute summary, status summary on bump maps? I feel we are. We've narrowed it down to 2 options and say these are the 2 options, and we know what's a good and bad, and then we're done, right? I mean, there's no more unknowns left.
Yeah, that's a fair assessment.
Okay, so we're ready here in my mind. Then this.
So Bapi, I think the question I had there, so what did you want us to cover in this section?
This is what it is going to be. This is the test chip. This is roughly our, not the budget, but any public details you want to share, which, these are the modes we're going to implement. This is what we know. This is where we need, these are the gaps in the planning side. We don't have the packaging done, and we need the validation vehicle. Anything you want to cover as what's done, what's open. That's really what I'm looking for, a summary.
Yeah, I think at least from my side, I think Satya, please chime in. But I think we are ready to talk about it.
Okay.
Sure, sir.
Ela, Derek. I don't know if Derek's still here with us or. What do you guys are ready in some sense? Elad? We lost him. Okay, we'll come back.
Oh, I'm sorry. No, I was on mute. Eric and I are here. It's the 30th we were talking about, right?
Sorry?
It's the 30th was the proposed date?
Yeah.
Yeah, that should be fine.
Okay. Well, in anyone else, I know of like 2.5 plans to build a test chip other outside this. One group has said they're not ready to share yet. Anybody else who wants to talk about their test chip plans, just to sort of whatever public you want to share publicly? You know who you are. Okay, connect with me offline. I think my main intent is to sort of say whether there's any part of the public infrastructure you can leverage for your own efforts and vice versa, and whether you can contribute to the public infrastructure without necessarily revealing details about what you're building. That's roughly what I'm aiming for in this session. Channel models, Javi, we know what we know, right? I mean, now there's a 60-ohm discussion.
Yeah, I think we can cover what we have, and then also what we plan on improving. Having additional models, so more traces per channel, We're going to have a shorter trace version of it. We'll also have a 60 ohm version now. So yeah, ready.
Okay. Package design, D sent me something. I think he says he's ready, so I'm going to mark that as ready.
Actually, just
Tested,
one real small thing for Javi, if you don't mind. This is a detail, but it should be quick. Were you able to check with the Alphawave folks if they could add in the clock traces, or like, kind of get the whole slice?
Yeah, so yes, they can do that. We can do that as well. It's just a matter of we're getting into vacation season right now, which is complicating things. But yeah, it can be done.
Gotcha. Okay, cool. Thank you very much.
Okay. DJ, I haven't seen Halil. I'm assuming he's on a break or something, but if you could please chase him down for us, or anybody else, somebody from the end users, who can represent whether the data being gathered meets your requirements, and anybody else who wants to chime in. Whether our plans for the data we're gathering are consistent with what drives the decision.
Yeah, let me chase Halil down. I think what we are doing is we are using Halil as, obviously we will discuss this in the end user work group, but we have one voice from there, and Halil will represent that. So I just need to find out where he is or what he's up to. I haven't talked to him in last couple of days. He must be tied up. So
Okay.
let me chase him down. Yes.
Okay. Is there anybody else? Actually, Anu, this was one thing I was thinking of for you as well. Is there anybody else who wants to poke around and volunteer on saying this is the kind of data we want?
Okay, from data from the test chip point of view.
Yeah, we don't want to do something and find out about 18 months or 12 months from now that oh damn, we screwed up.
Okay. Okay. I'll have to talk to a couple of experts within the organization to see what we're looking for. But yeah,
Yeah,
you can pencil me in, and then I'll let you know.
Yeah, so one from the end users and one from the semis, basically. So, and anybody else who wants to communicate with Anu or something, my main goal is to make sure we're not missing the obvious. That's about it. Okay, DJ, this last thing is in my mind sort of a program management thing that you're going to look at it and as a program manager and see whether there are any consistency gaps in the plan of record. Maybe that's okay. So maybe I should have said that up front. What I'm thinking of is making a POR, to use an Intel term, for this project. This is one painful learning I had from the board POC, is that I wish I had done this earlier on, basically.
Yeah, I'm happy to support here, Bapi.
Okay, so you're going to drive this. Okay.
So
okay,
this particular part will be for each of the elements, bump map, test chip design, channel models, packaging design. I think in every element, we need to have a plan of record as we transition from one topic discussion to the other. We won't do that until we have locked and agreed on the plan of record. And obviously there could be some dependency back and forth. Something comes out of channel model, it can go back and affect bump map. So, it would be hopefully not too much of iteration, but happy to support here.
Yeah, and the aim for the meeting is just to identify them, not to close them.
Yeah, no, not identify them. Basically, the goal is to lock them, meaning plan of record is plan of record. So we have to lock the plan of record. That's the key. Like everybody.
So, okay. Let me come back to this in a minute. Then I'll tell you what I was thinking, and you can change it as you wish. Okay, this one I really need help on. Somebody who can help at least sort of say, okay, how do we getting from the chip to the package to lab is somewhere I believe we have a huge gap, and I at least need some help on identifying the steps and things like that, and whether anybody is able to lead the discussion on this.
So, Bob, can I just clarify one thing? By that, do you mean who is supplying the packages and who's doing assembly, and where, like, I guess, is this more of a logistical question or a yeah, like what exactly is the question you're trying to answer, I suppose?
So at least in my head, I believe it's in our interest that even if you're designing your own test chip, that everybody could somehow use a common validation infrastructure to bring up the test chip and then see whether it's working, etc. And so I'm trying to figure. But what are the steps? What is the tooling we need? Do we need? Which software will we use? Or is there any sort of and where will the data sit? Who is going to build the boards? Which Dell
Yeah,
platform? So step one in my mind is just identifying the steps, basically. Sorry, go ahead.
I think that's a very worthy goal, but I think there's a number of just very practical things that will make that probably logistically difficult. Not the least of which is that if these things are designed to operate in package, like that implies that most of your testing will be embedded circuitry within the individual sort of designs of the PHYs, which means that everyone's going to do something. If everyone does something slightly different in how they build the PHYs, then the way in which you test it, just the logistics of which registers you poke and how you configure things and so on and so forth will have to be a little bit different. So in other words, I think you could specify things like, okay, hey, we should run the following PRBS sequences and collect margins across these certain things and so on and so forth. But actually having a single physical setup do it would really mean n setups with n different pieces of software and so on and so forth.
Okay. So makes sense. And if we could reach that conclusion in this 30 minutes, I'm happy to. But I'm not sort of mandating that we need one. I'd just like to sort of make up our minds one way or the other.
Fair enough.
Bhapi, I think my input is here, like we need to separate it out. Is this whatever the logistic issues from the test plan? Are you looking for a test plan? Or are you looking for a?
Okay, so I sort of know what I want without the ability to describe it in detail. So my understanding of where we're going is, you guys are going to build a test chip. You're going to package it into a die. Excuse me. You're going to take two die and put them into one package. And after that, you're going to have some kind of a validation board and a validation setup. And if somebody comes forward, say 6 months from now, and builds their own test chip, how much of what exists can be reused is the basic question I'm trying to figure out. So that somebody can come about 6-7 months from now, build their own test chip, and then say, aha, I can interoperate with Sid and Satya's test chip or with Elad's test chip, assuming it's available to interoperate with. You can't reuse the package, you'll have to build your own package, but basically the way forward is sort of reasonably clear. So is that a meaningful goal, or should I just scrub it? And if it's a meaningful goal, how do we get to it?
So Bhapi, since this is a chip-to-chip interface, it's just about defining the package substrate, right? A common, some kind of a package substrate model with S parameters or whatever for the interconnect, right? That people have to follow and go build build around that, or build substrates with those channels in mind, and then they can do everything outside of that. They can do on their own, right?
All right. My question is, can you save them from doing it on their own? So you should say, look, if you build a substrate with this package, with this ball or bank, you can reuse this board, you can reuse everything else, and here's this whole thing that's available to you.
Yeah.
Or is that a dumb goal?
I think most people who are going to want to understand, they'll be most people are focused on the package substrate models, right? I think once you mount the package on a PCB or a board, which is a validation vehicle, we can. I mean, we are very open. We're certainly very open to kind of providing all that information to anybody who wants it, right? To the extent that they want to use it, they can certainly use it, but it may or may not be super meaningful for them. They might just do it on their own anyway. And they really want to pay more attention to what we use as a package substrate model between the two chiplets, because really that is what they need to know to understand whether the IP actually works, right?
But this is not meaningful, is what I'm hearing. Then, it's okay. I'm not the.
Yeah, I think my suggestion would be to focus more on converging around what the package substrate model should look like, right? So that those model parameters are available in the public domain, and people who build the test chip build around those models, and then we can ensure interoperability across vendors if we need to, but certainly two chiplets from the same vendor will have those models that other people can use. And then the outside validation vehicle, the boards, the software, all that kind of stuff, right, can be more proprietary, because I think trying to converge the infrastructure around all of that, I think that, first of all, I don't think there's a very high ROI there for end users or other people who will eventually plan to use this. They'll do it themselves anyway.
Okay.
And we'll just slow ourselves down. I think that's just my opinion.
Okay.
So, a quick question: what does outside validation mean? So, I'm looking at the bullet point package substrate model outside validation. I'm not
This is a
familiar
separate
with.
bullet point beyond package validation infrastructure. That's the way I'm understanding what's, just so we're clear. Okay.
Yeah, I think we need a package substrate model which is open. It does not behoove with the industry that that's the only one which will be in existence, but we need one model which is open, and the first one which we can make open is the one which is used for creating a BoW test chip connection across two BoW test chip. I think that whole infrastructure should be open, which is packaged with two BoW test chips and the package substrate model which goes with that.
Okay. In that case, this is no longer relevant. I'm going to toss this. Everybody will do their own, basically, right? Maybe it's worthwhile having a discussion on the logistics, just so we're in sync. Is that a fair way to put it?
I think that's partly covered by like CDX efforts to describe what the hardware actually is.
So there's a very test chip specific effort, just that everybody's got everything covered, not to do with sort of generalized, literally very narrowly focused on the test chip.
Yeah, but you just describe what your test chip actually is, and then apply tools to work out what the model is.
Okay, maybe I'm doing this. Okay, then I'll come. Do we have? Okay, maybe I'll ask this a different team. Just beat this flog this dead horse one last time. Do we need to have a discussion on what happens from when the die is made through package to bring up? Does somebody have to detail that and the logistics of that or not?
I think the logistics are.
I mean, yes. Go ahead, please.
Yeah, I was just a quick point. I think we need to have a discussion, as DJ was saying, around on die to package, right? There has to be some kind of a common thread across that. But I think beyond package, once you have assembled the two die into a package, where the package substrate models are in the public domain, what happens outside of the package, how you mount the package onto a board, how you test, what kind of software, GUI, what kind of interfaces you have coming into your validation board that has that MCM package, that can be left to the folks who are building the test chip.
Yes, I agree with Sid. In fact, I don't think there is any development required there because that already exists.
Okay.
Companies do this already, right? I mean, they have packaged devices and they build boards day in and day out. What we are doing is we are innovating what is inside the package by building chiplets into it, and then that's where a lot of unknowns lie.
But we do want to know that the companies doing this have covered the obvious stuff, right? I mean, just so from a POR perspective, we want to know that you're doing what the quote unquote obvious things that need to be done are being done.
Yes, and I think that's that. Yeah, without those boards and software and all that, I don't think you can really do much anyway, right? So obviously the companies who are building the chips will have to build that stuff. To the extent that we need to discuss it in this forum, I don't know how useful it is.
Okay. So at least saying we recognize that this needs to be done, and I'll
Right.
leave it at that for now. Okay. Okay. Then this may. So then in that case, Javi, is this you? Unless Javi's disappeared. No, I lost Javi at the moment. It has to be him. Who else is Javi the right guy? Could we just twist his arm and ask him for this, or can somebody help me out and tell me one way or the other?
I mean, isn't that the channel model basically?
Yeah.
So I think you just delete this item and call it covered.
Yeah, you already have that in 3, right? So
But just give him more. But then, but I guess you're saying this is what we want covered. So covered in channel model. Okay. Okay. Then in that case, we're in reasonably good shape, Anu. I mean, really, it's the objectives and the discuss, and this really won't be ready until the day off. And we really have to just sync up on what details, what data we want, and then otherwise we're in good business, right? Good shape, right?
so are you still thinking this Friday?
No, I'm not thinking this Friday.
Okay.
I'm saying we're reasonably ready, correct? As far as I can have this discussion.
Yeah, seems like.
Okay. DJ, from in terms of, one of the primary objectives here is to have a single source of information that anybody can come to for funding, anything else. Is this going to meet your needs? This POR discussion?
I think it is. I'm assuming in the POR we are going to have timeline embedded. I'm assuming we are not talking about what aspects of PR, but yeah, I think this should be a very good first start. I think one open question which I repeatedly get is who is going to program manage or project manage a lot of this work, because obviously we are doing this in open with multiple companies in a single company. Who is going to drive it, right? That's the phrase I've heard internally used. I would like to bring that discussion in here as well to figure out our model of making all of this work, right? How are we going to make this operational by getting set of folks driving it, or exactly how is it going to work? And honestly, I don't have clarity in my own mind either, because we are all working for different companies and we are loosely coupled as a community, right, under OCP. But for driving it together, we have to do it a lot stronger effort.
Yeah, I mean, I suppose Sid and Satya should speak for themselves, although I imagine they'll echo what I'm saying. I think for ourselves, and I imagine for them, that this is we're going to end up driving a lot of this anyways, because this is a thing that that we're sort of we're pushing on regardless. So I think we ourselves are going to have to be sort of driving a lot of the execution, kind of no matter what. And so I guess maybe the question is, sort of, is there some other higher level sort of, management or whatnot, which is a valid discussion, but at least in terms of who's going to be driving it, I think the answer is, Sid, Satya, and their team, and Eric, myself, and our team are certainly going to be driving a lot of this.
Right, but so Ella, you will need some interaction with others, and then maybe clearly defining that API, for lack of a better word, would be a useful thing. We're hoping you're going to drive a lot, and even with that, I'm reasonably sure we'll need some kind of API between you and the rest of the world.
Is that different than sort of the meetings we're having now? I mean, by the way, I'm perfectly happy to do that. I'm just trying to make sure I understand the.
It comes down to when you want. So the meetings we're having are generally tend to be sort of thought exercises that we can get away with in terms of writing stuff. One of the things I noticed on the board POC is at some specific point. I'll give you the last example we faced, right? Like We had in the board POC once we had a respin of the NIC interposer card. We still couldn't get it to work, and finally the debug involved people from 4 different companies, and we had to sort of put it together ad hoc. And we lost quite a few days in that process trying to figure out, where is it, who needs to be involved, and can we get their time. So if we're able to sort of identify all this up front in terms of, hey, this is going to happen and this is where 2 companies will likely need to interact, we probably could get people prepped ahead of time. That's basically, you're basically seeing me reacting to the way with the lessons learned in building the board POC.
Yeah, and this also makes it easy, for companies who are funding. This question gets asked, right? So how is it all going to be driven? Who is going to drive it? And I think we need to agree on a mechanism on how we are going to drive this as a collective while we are all part of different entities.
Good lucky thing is it's under your name, DJ, so it's all yours. Okay. All right, so then let's get to DJ's last question. What do we want in terms of each section? And this is my strawman proposal. I'm happy to list any opens other than funding, because DJ is obviously working on this, and it's a known gap. Outside of that, I was thinking that you list assumptions, list what we've agreed to. This is my proposal, and maybe I heard timeline as well come in somewhere. This is what I have. Anybody have any alternatives or changes? I'm just gonna kill this. Anyone? This is good enough?
Yeah, I think it's a good start.
Okay. Then in that case, so date-wise, we're saying the wait, what is today? I'm sorry. 23rd. So we're going to aim for the 30th of July. Is that where should we aim for that? Or well, our options are either to just do it next Wednesday in a 2-hour stretch, or or Friday. Which would you prefer? I would personally prefer a Friday because we already have a BoW meeting on Wednesday for 2 hours straight. So that would be my bias. If nobody has any objection, I would say the 30th Friday. DJ will have to sort of twist Ravi's arm to give us that slot, if that's okay with him.
I think that should be fine.
You're already more than 6 months through the year. Okay, if this makes sense, I've covered everything I wanted to. Anybody have any other opens, anything else we should cover? If your company if you would like to share your effort, please do so. I'll make some time.
Bapi, quick question. The spec is on GitHub, which I accessed, but the document I think DJ showed last time, is that in a Google Doc, the one that we share internally?
Yeah, give me one
sec. Point of view, not the spec.
Yep.
Yeah, I think the funding proposal.
Yeah.
Let me put a link to the spec and the.
Yeah, I would appreciate that link too. Also,
yep.
I sort of got lost with all the stuff going on. Thank you.
So funding. Where the heck is
I can post the link if you don't.
Yeah, I got it. I got it.
Okay.
And again, my standard warning, this is public information. Please do not post any company secrets, anything. Funding proposal.
And
Spec.
at the same time, if your company has a particular viewpoint on the funding, especially on gives and gets, for instance, or any other area where you can contribute, please do add your edits into the document. We are looking to make this as strong as possible from all company perspective. End users started this effort, and now we are kind of opening it up to a wider group of companies so that uh, the effort which we are trying to launch here is meaningful to everyone in different ways, right? So end user benefit in one way, but your company also can benefit in a different way. So the idea is we can't think of all different perspectives. So it's important that you take your company perspective and try to add it into the document. Otherwise, it may not get reflected and we may not be ever aware of it uh, until later point.
Actually, DJ, that's a really good point. I'm wondering whether do we want that discussion on gives and gets as a part of this, or that's a separate thing?
We should review it, Bapi, during the call, and then let people comment on it.
Let me add that as an agenda item, a review of the funding proposal document. That should be the
Yeah.
final thing.
Yes.
So I posted a link to this doc in the chat window. If you could please see that you can confirm that you can access this. Okay.
And Bapi, one other question. The Friday call, is it because we are kind of making it into a dev sprint? Is it only for a limited set of participants based on who you are deciding, or is it open to everyone? Curious to hear your thoughts.
Oh, no. The call is open to everyone. What I don't want this to become is like, anybody has a doubt and then sort of derails that, why did you make this design decision versus that design decision? But I'm happy to take everyone's questions, aggregate them, and then we can discuss them in a test chip meeting. But this meeting is more like, hey, this is the POR we've all agreed to as of now. Not to have a sort of a good, solid discussion on the technical merits of one option versus another. If that
Sounds
makes
good.
sense. It's open to anybody who wants to listen. The whole point is hopefully more people listening and saying, okay, I'm going to align my company's plans with this, or if you gave us this, we'd be more interested in participating. Right. The whole point is to open it up to everyone. But it's not to become like a, well, why don't did you guys ever think of this really clever bump map that I came up with? Was that's not the point. That we'd love to hear that, but in a different meeting.
Got it.
So let me just go down the primary list of victims here. Namhoon, Satya, Ken. Is Ken still on or did he leave? Okay. You guys okay with this? Sorry, man, I can't hear you.
So do you need any presentation or?
Yeah, I just want a presentation of what has been agreed to, the two bump maps. As far as I know, we've settled on two bump maps, one from Satya and one from the Ken's bump map are the two ones. One is in the spec, one is going to be implemented, right? So the idea here is this for each section. Assumptions, what we've agreed to, any opens, any targets that we're looking at.
Sure.
Sorry, Anna, I didn't see that. Okay. Then Sid, I'm assuming it's okay with you.
Yes, Bapi, this is good.
Okay. Elad?
Yep, that's fine for us.
Okay. I should say anyone else, but anyone else. Javi is not on with us right now. Okay, D is sent some stuff in. DJ, you're going to close the loop with Halil. Anu, you're okay, right?
Yeah, I'll get back to you, Papi. I'll
Sounds
try
good.
to figure this out. Yeah.
Sounds good. Okay, thank you. And then DJ, these two sections, we'll figure it out.
Yep.
Then I think we're done. All this stuff is not relevant. So we're saying all the stuff is a corner, and this is the content, 30th July Friday, and you see the links to the funding proposal and the spec at the bottom. Awesome. Thank you. This is great. If we can get all this in one place, I think we'll be in good shape. Anyone? Oh, one last thing. Sorry, I knew I forgot it. One last thing, and we can decide after the POR. I think it's good to, I know it'll be good to have something about the test chip in the November summit as well. So we'll have to fashion an abstract. I'm going to volunteer someone from this group to present on the test chip, or we'll make it a panel basically. So I've already penciled in a panel for the test chip at the November summit. Just FYI. Make sense?
Your abstract submission deadline is in 2 days, right?
It's not. Wait, I thought it was July 31st.
No, isn't it the 23rd?
No,
Maybe not.
23rd. It's 23rd this Friday.
23rd.
Oh no, then we're kind of screwed, man. I read it as 21st. Okay. Oh no. You sure it's the 23rd?
Yes, because I'm working on a whole bunch of stuff right now as
Yeah,
we
that's
speak.
what Ravi also told me. That's what
Oh
I,
no,
because
then
I'm
we're
submitting an abstract
royally
for cost
messed
modeling.
up.
That's why I
Okay.
know.
Okay, then we have a problem, DJ. Okay, I'll sync with you offline.
So, Bapi, let's sync offline and we can spend some time, even late evening or whenever, to finish this.
Yeah.
It shouldn't
Okay.
be very difficult. It's not very difficult.
Okay.
Yeah, no,
All
I
right.
think writing up the abstract's not difficult. Some people need it approved by their companies, like mine, for some unknown reason, because there's nothing proprietary in it, but it had to go through legal and it's sitting with some senior VP right now. So I just, warning, I think the person who has the easiest path forward should probably submit it.
Yeah.
Yes,
Just
completely
saying,
agree.
some companies, yeah, I think even Google with Mudassar, they give them a hard time too. So it's not that trivial.
Wow. Okay, here I've been operating under the assumption it's the 30th. This is terrible. All right. Okay. Anybody else with any other opens? If not, everybody gets 15 magical minutes back. Thank you.
Thanks, Bapi.
Thanks, Bapi.
Thanks, guys.
Yep.
Thanks, guys.